So I was discussing what is the modern definition of organic chemistry. So study of carbon and its compounds. अब ये जो carbon and its compound entirely, that is called modern definition of organic chemistry. Now usually CO2, CO, carbonate, bicarbonate, HCN, HNC, these are excluded from organic compound. So as I was saying, there is no fixed reason why. Okay, but but with practice we have considered कि इनको हम नहीं लेंगे. Okay, now this is the modern definition. Next comes that what is the reason why we have this special branch? Okay, so characteristic of carbon that you need to know here, atomic number. So property, that is why I have cut that. No, I don't want to intend the word property here. It is atomic number, atomic mass, electronic configuration, covalent radius. This, I think all you already know. These are the properties of carbon. Now, then the carbon, what is so special? Its catenation property. Yes, catenation हमें important है. What is catenation? Is self-linking behavior, right? Now, this is a very specific property. Catenation is characteristic because of the high BDE, bond dissociation energy of carbon-carbon bond. I'm not saying that these are the highest bond dissociation energy of the entire periodic table, but this is quite high. And down the group, the size increases and the electronegativity will decrease, and thereby tendency to show catenation decreases, right? If we go by property, other properties, so we have others who can have catenation are, yes, silicon, germanium, but they are much less as compared to carbon. And the reason is the relative decrease in the bond dissociation energy. Then we have to know about the graphite, diamond, and fullerene, which are the allotropes of carbon. I think these are phase 1 notes. So I'm just moving forward. Okay, wherever I feel some mechanism, something important, I will stay back. Okay. So these are the bond lengths. In graphite is 141.5. Then diamond, we have single bond, which is of 154 picometer. Fullerenes does have different type of bond lengths, like single bond is 143.5 and a double bond, which is of 138.5 picometer. Now, fullerenes show aromatic nature, right? And diamond is a very dense, hardest substance on earth. So it is used as abrasive. And it has very important role in day-to-day life, but on an expensive side, of course. Okay. So see, graphite is like this. Layers, layers, layers. So it is slippery. Diamond. Whereas fullerene has a ring of 5 member, 6 member. Again, there is 6 member, right? So one 5 member ring is bonded to 1, 2, 3, 4, 5, 6 membered ring like this. Is that correct? And one 6 member is bonded to 3 5 member and 3 6 member rings. That is how a structure of fullerene is there. Take. It is very important to know that graphite is thermodynamically most stable allotrope of carbon, and therefore heat of formation of graphite is taken as 0. Take. Because reference frame wise we take it as 0, delta H formation of diamond and fullerene are 1.90 and 38.1 kilojoules per mole respectively. Okay, these are the usual behaviors, are the properties that you need to know. Yes, Rohit, what do you want to say?
Ma'am, you said fullerene is aromatic, then why does it have 2 different bond lengths?
Yeah, because need not, like even in naphthalene and all, you have different bond length. Na? If something is aromatic, does not mean all the bond length will be exactly equal. That depends on their resonating structure, Rohit.
Right, okay, thank you.
Right. So again, this is a primitive example, like what is sp3, what is sp2, and so I'm moving forward. What is sp? Like these all standard bond angles and these. You know that as the percentage of S character increases, the electronegativity of hybrid orbital will increase. So like sp will be most electronegative and sp3 will be the least electronegative of the usual three hybridizations that we will need in organic chemistry for carbon: sp, sp2 and sp3. Please write these bond lengths somewhere in your notes. If you already have, very good. If you don't, then please write. Carbon single bond carbon 154, carbon double bond carbon is 134 picometer, triple bond is 120, and double bond of benzene is found to be 139 picometer, which is certainly intermediate between single and double. Okay, done. Indicate me that is done. Move.
Yes, ma'am.
Okay. So structural representation. Yes, again, I don't know whether you are reading NCRT or not, but if you have not read, please make it a ritual. Daily read some pages of NCRT. Compulsory reading of NCRT is needed for both mains as well as advanced. Please do not neglect. So if you would have read it, complete, condensed, and bond line, three representations are there in NCRT. Complete matlab you write each atom, you represent each bond, then it is complete. Condensed, you just imagine as if all these bonds are like stick and you compress, all the sticks are now invisible, and simple CH3 dot CH3, CH3 dot CH2. This type, if you are writing, then it is condensed. Okay, yes, you have to remember that uh, while writing this type, whatever like CH and CH, if I'm writing, so whatever bond you feel is not satisfied will be satisfied amongst themselves. So maintaining the tetravalency of carbon, you have to assume the proper structure. Okay. I would like to add one thing, beta. All of a sudden, the weather conditions in Hyderabad has just deteriorated. So, in a case, if electricity gone and network gone, just be in the meeting. Okay, I'll go on the generator or the inverter. It will take few minutes to for me to be back. Okay, I can see across the window. All of a sudden, it is a little windy and the weather is like that. I may get an electricity cut or something. So if it happens, just be in the meeting. Okay, do not leave. Wait for me to be back for in three minutes, 4 minutes. I'll be back. So let me continue. So bond line notations. When we talk of bond line, then we do not represent carbon and hydrogen. We do not represent, rather, I should reframe, we do not write carbon and hydrogen, and we write simply the bonds between those atoms. But if there is any other atom than carbon hydrogen, then we do write them as proper atoms. Like, see, ethane, I'll just put a stick. Okay. Ethene, I will put like this. Ethine, I will put three dandas. Ethanol, I will put like this. But I have to write now OH. In case I would have not written OH, if would have left like this, then it is taken as propane. Okay, CH3O CH3 and all these. Right, benzene, I will write something like this. Some important molecules that you need to know, of course, benzene. Yeah, please see how many pure or unhybridized orbitals are there in C6H6. Similarly, you can practice 1,3-butadiene, right? Kindly do this question. Maximum number of atoms that can be in one plane in 1,3-butadiene is. Now, what is cumulative diene of polyenes? Allenes. So like these will be allenes. The word is derived from all enes. Like all bonds are enes, then it is called alkenes, right? This is the geometry. Of course, for initial phases, it is right. Now coming to degree of unsaturation. Now, degree of unsaturation is also known as index of hydrogen deficiency, double bond equivalent, unsaturation index. All these are names of degree of unsaturation and the abbreviation DOU, IHD, DBE, etc. Okay, C plus 1 minus H plus X minus N by 2 is the formula Very good. We know the formula. Now, the very important point is, what is degree of unsaturation? Degree of unsaturation, please remember, is a chemical terminology, is a mathematical expression, and unsaturation is a chemical terminology. Okay, so what do I want to say with this particular thing? See, if I say a compound is unsaturated, what does it really mean? So I was telling that degree of unsaturation is DOU, IHD, DBE, unsaturation index, and there is a formula. Very good. We have a formula. How to use it? Do we depend on formula? I'll say not always. We have to be very open, like how to use this particular concept. First, let me differentiate for you what is unsaturated compound and what is degree of unsaturation. Okay, so unsaturated compound, if I say this compound is unsaturated, it should have some chemical behavior to satisfy, some chemical reactions to exhibit, then it is for unsaturated compound to be called. Okay, now what is that behavior? A compound will be called unsaturated only when it shows unsaturation test, which are bromine water decolorization or cold dilute alkaline KMNO4 decolorization. These, if we see, then we call those compounds to be unsaturated. Now, when I say unsaturated compound, I do not intend to say that there is a presence of pi bond. For example, yes, benzene has a number of pi bonds, but does not to be inferred as an unsaturated compound. Cyanide, yes, it has pi bond, nitro, carbonyl, but these are the compounds which will not give the electrophilic addition reactions which are used, okay, which are used for compound to be named or considered as unsaturated compounds. So for a compound to be referred as unsaturated compound, compulsorily should give bromine water reaction or Bayer's reagent test. That out of these, if it shows some reaction, then only you call it unsaturated compounds. Whereas when I say a compound, whenever I say find a degree of unsaturation, degree of unsaturation, beta, is a mathematical condition. Okay, what is it? It is a mathematical condition in which we define some condition. Now, what is that condition? Let me tell, please listen carefully. Number of moles of hydrogen molecules required to convert given molecule into fully saturated, in bracket we'll write all bonds should be single bonds, comma, open chain structures, okay, is called degree of unsaturation of that compound. Let me repeat. Number of moles of hydrogen molecules required by 1 mole of a given compound to be converted to fully saturated open chain structure is known as degree of unsaturation of that compound. Absolutely clear now? So degree of unsaturation is something which is a mathematical condition. Here we are not saying it should give this test, it should give that test, or it should behave like this. No, nothing. Now, when I have this, that okay, degree of unsaturation is a mathematical condition, after that you have to think for two things. Two things, what I want to say is either the question will be in terms of formula or it could be in the terms of structure, right? So if it comes as a formula, right? If it comes as a formula C6H6, C3H6, so like this, in these, the use of this formula is very appropriate. You can go by this. C plus 1 minus H plus X minus N by 2. You can use this and continue your question. Okay. But if you come across with a structure, then it is your choice whether you convert it to the CXHY type formula and then apply that degree of unsaturation formula, or you can directly go by, like for benzene, just remove the pi bonds. One pi bond will require two hydrogen atoms. two hydrogen atoms, one hydrogen molecule, so 3, and one ring opening, so total DOU is 4. Okay. Similarly, in naphthalene, 1, 2, 3, 4, 5, 6, 7, DOU is 7. Right? In cubane, this compound is called cubane. 1, 2, 3, 4, 5. Right? And so on. 13, and this is how you can do. Now, it is entirely your choice, whichever way you are comfortable, you can use these reactions. Okay. Is that clear how to solve these questions? But you need to know use of degree of unsaturation to have good command over other questions in future. Now let us start with the organic compound are classified as. Again, I am using reference as NCRT. So acyclic or open chain. Yes, Shrey, please speak.
Ma'am, can you please go back to the last slide?
This one.
Yeah, number 6, why is it 2?
Shrey, I am using 2 because I will have this as 1 and this as 2, na beta?
But why is NO2 counted as
Oh, then you didn't pay attention, Shrey. I said degree of unsaturation is a mathematical expression in which number of moles of hydrogen molecules required to convert given molecule into fully saturated open chain, fully saturated one here and one here, two, na?
Okay, so I mean, just all double bonds or triple bonds to see.
Yes, all double bonds, all triple bonds, whether they are only of carbon-carbon or other species.
Okay, thank
Is that clear?
yes, sir.
Okay. So that is how we do a degree of unsaturation. Yes, Sanjay?
Ma'am, can degree of unsaturation can be defined for ionic species like carbocations or carbanions or anything else of such?
I don't find the need for that. I don't know how will I hydrogenate them. These are the reaction intermediates, Sanjay. It is a very hypothetical question. Why would I do that?
Okay, ma'am.
So saturated and unsaturated we were doing. We have already defined now the what is the chemically saturated and saturated. Here the chemical, I'm not saying degree of unsaturation. Then here comes the cyclic or closed chain or ring compounds. Okay, so it is homocyclic or carbocyclic and the heterocyclic compounds. So if I talk of homocyclic, it could be again alicyclic or aromatic. Aromatic are further as a benzenide and a non-benzenide compounds. Heterocyclic as alicyclic and aromatic compounds. Okay, like that we classify. Now, there are some important terms that you need to know, like acyclic. Any compound which is open chain is called an acyclic compound. It could be saturated, it could be unsaturated. We are not referring anything with respect to this. Any compound which is open chain is called acyclic compound. Like this ether, this alkane, all these are called acyclic compounds. Alkenes or alkynes are unsaturated but still are acyclic. Okay. Cyclic compounds are alicyclic. They will be called cyclic compounds are either alicyclic or aromatic compounds. Coming to what is alicyclic, as we have defined, cyclic is of two type, ali and aromatic. So alicyclic is alicyclic compound contain one or more rings, which may be either saturated or unsaturated, but do not have aromatic character. So they can be saturated and unsaturated, but they should not have aromatic character, right? Then they are called alicyclic. Out of this, there are homocyclic, which are like this, or it could be heterocyclic, like oxygen, nitrogen, sulfur, all these are heterocyclic compounds. Aromatic, when they satisfy the condition of aromaticity, then it is aromatic. Either it could be benzenoid, it could be heterocyclic systems, it could be non-benzenoid. Non-benzenoid bole to it should not have a benzene structure in it, like tropone, cyclopentadienyl, anion, and so on. Then we have the types of carbon. Please remember this is a general definition that we are using but modified as per the latest NCERT. 1 degree of primary, okay, when the carbon is further connected to either one more carbon or no carbon, and as per that methane is now taken as a primary carbon. Okay, so 1 degree of primary. 2 degree when a carbon is further connected to two more. 3 degree connected to 3 tertiary, then 4, and so on. You must be aware of this terminology also. Vinylic carbon, carbon double bonded carbon. This carbon is called any of these, huh? This and not this one or this. Any of this double bonded system may say we take one carbon will be referred as vinylic carbon. Allylic, see this propene system. In this propene system, this sp3 carbon is called the allylic, right? This is the basic. Now, if I have this type, yes, I have two allylic carbons, this CH3 as well as this CH2, two allylic. Benzylic, benzylic ring, and then the next carbon to ring. Immediately attached next carbon to ring will be called benzylic carbon. Okay. Phenylic carbon is the carbon present in the ring. Is that clear? Phenylic carbon is the carbon present within the ring is called phenylic carbon. Types of hydrogen. Similarly, we proceed at the primary hydrogen, that is the hydrogen attached to primary carbon. Secondary is the hydrogen attached to 2 degree or secondary carbon. Tertiary hydrogen, carbon which is 3 degree, the hydrogen attached to that 3 degree are called tertiary hydrogen or 3 degree hydrogen. Okay, and similarly, vinylic hydrogen, as we just discussed, vinylic carbon, hydrogen attached to vinylic carbon will be referred as vinylic hydrogens. Okay, so this is how they are named. Moving to allylic hydrogen, same way benzylic and phenylic. Count number of allylic and vinylic carbon and hydrogen. No need for you to do at this stage. Find number of benzylic carbons in the following compound. Yes, you can do that. Number of 1 degree, 2 degree, we do not need to stop. Coming to functional groups. An atom or a group of atoms in the molecule which control most of its physical and chemical properties. As the name suggests, the functional part of the molecule is called functional group. Okay, the functional part of the molecule is called the functional group of the that molecule. It could be an atom or it could be group of atoms. Okay, so there are so many functional groups. Even alkene and alkynes are also type of functional groups. They are taken as a separate functional groups. Similarly, you must be aware of the fact what are the degree of alkyl halide, degree of alcohols, degree of amines. But yes, there is a difference in degree of alkyl halide alcohol versus degree of amines, right? Alkyl halide alcohols are like primary, secondary, tertiary, similar to the way we refer the hydrogen. If halogen is attached to a primary carbon, then we call it as a primary alkyl halide. If it is attached to a secondary carbon, then we call it a secondary alkyl halide. Tertiary carbon, then tertiary alkyl halide. Whereas in case of different degrees of amines, we refer degree with respect to ammonia. Okay, the number of hydrogens we displace from this ammonia and form amines. If I displace only one hydrogen, RNH2, then it is primary amine. Now I am totally independent of what the nature of the carbon with which my nitrogen is attached. If I simply remove two hydrogens, I will call it secondary amine. If I remove three hydrogens, it is called tertiary amine, right? Again,